engineering and the risks on human nature. Many of you are probably thinking, what even is genetic engineering? Genetic engineering is the manipulation of genes in living organisms by adding, changing, or removing specific sequences of DNA. A popular technology used for genetic engineering is CRISPR. With CRISPR, we can cure diseases, treat genetic disorders, and many say better human lives. But to what extent is this scientifically possible?
So how does genetic engineering work, and how has it affected the scientific community? One of the main ways that scientists are able to perform genetic engineering is through the CRISPR-Cas9 method. CRISPR is a family of DNA sequences found in prokaryotic organisms that seek out specific DNA sequences. Cas9, as can be seen in this diagram, acts as scissors that cut out pieces of DNA that are unwanted. This creates entirely new DNA that has been mutated. Through this, scientists are able to rid a person of many genetic diseases, such as cystic fibrosis and sickle cell anemia. Not only can CRISPR be used for medicinal reasons, but it can also be used for more physical reasons as well. For example, genetic engineering can be used to change physical appearances, as my colleagues will talk about later. The scientific community has truly been affected by the development of genetic engineering. Two geneticists have been subject to much controversy. One, for example, is He Jiankui, the Chinese geneticist who genetically engineered the twin girls known as Lulu and Nana. He altered their DNA to make them resistant to the human immunodeficiency virus, known as HIV, of which their father is believed to be a carrier of. There is an ethical issue when it comes to Jiankui's actions. For example, HIV is a very treatable disease, as the chair of conference at the Second International Summit on Human Genome Editing, David Baltimore, claimed. The research was not medically necessary, as there are other treatments for HIV. Jiankui now faces up to 3 years in prison, a $425,000 fine, and will be banned for life from any further involvement in reproductive medicine. Finally, we have George Church. His controversy lies within what his lab wants to do with genetic engineering. According to Scott Pelley, a correspondent with CBS News, George Church's lab at Harvard Medical School is working to make humans immune to all viruses, eliminate genetic diseases, and reverse the aging process. If possible, this could spell the end of genetic diversity within the human race without proper regulation. So, how will these controversies affect the future of genetic engineering?
Paul Knopfler is a biomedical scientist and writer focusing on stem cells and genetics. He talks about the process of genetic engineering like a genetic Swiss Army knife with a bunch of tools in it, like a GPS and a magnifying glass to home in on a certain sequence of DNA. And then the next tool is like scissors, where they can cut open the DNA, and then a pen where you can literally rewrite the genetic code. He talks about how it's that simple, and it may seem crazy because something so drastically changing in someone's body shouldn't be that simple, and it can cause many risks to human nature. Jim Kozebeck of Time magazine talks about how editing human genes are permanent and they can be passed down from generation to generation. He talks about how sometimes the body can correct itself from diseases, but scientists can now enter a correct genetic sequence to cure diseases, and these corrections could be passed on to offsprings of the genetically edited people. If there was altercations added into someone, then it could be passed down through generations, and it could cause health problems in the future. Megan Maltini of Wired talks about how in 2018, a scientist tried to do a genetic engineering method on 2 babies to cure HIV. This also was known to shave years off people's lives, and she now thinks of CRISPR as an early death sentence. On the database opposing viewpoints, different controversial concerns are shown of genetic engineering. As you can see, only 52% of people believe it would be used for unethical reasons, and then 45% think it would have unintended effects on human evolution. And then 33% believe it would have unintended side effects, and then only 8% believe it would be affordable, which proves that it is very expensive and it could not reach many people. The counter side of this argument would think that CRISPR should be used because it can cure inherited disorders and acquired disorders, like AIDS, cancer, and heart disease. With all this research done and with much more to come, it almost seems as the future of our genes is in our hands.
So, what are some ways that genetic engineering can impact our society today? Genetic engineering is classified into two different uses, one being ethical and one being remedial and one being enhancement. Remedial being the elimination of diseases and harmful disorders, and enhancement being cosmetic modifications like hair color and eye color. Dr. Schufel is a science communications professor at the University of Wisconsin-Madison, and he surveyed about 1,600 members of the general public to record their views of genetic engineering. And the results came out with 26% stating that it was acceptable and 51% saying it was unacceptable. Additionally, the results came out with 65% stating that it was acceptable for remedial use. It's possible that genetic engineering can be compared to plastic surgery. And so some may wonder how plastic surgery can be normalized in our society today, but genetic engineering cannot. It mainly comes down to the capabilities of both procedures, as plastic surgery enhances and enlarges bone structures and features, while enhancing and genetic engineering can alter the whole structure of an embryo's genetic material before it is even born. You can see here that genetic engineering is usually done a little after in this stages of development, and it's conceived a little after the embryo is conceived, from the first week to 2 months of the baby's development. So, if any feature of the child can be chosen, from eye color to gender, wouldn't it be similar to just going to the pound and just choosing a puppy that you have the desired gender and features for? Through genetic engineering, it has a good intention of possible aid in society, but for medical reasons and self-esteem, there are too many risks attached that could harm human nature. Genetic enhancement is likely to make societies more unequal, and equality of opportunity will become more and more meaningless. For instance, totaling the labor costs with the total of equipment comes to about $1,800. So in most cases, those who will get this procedure done are financially capable to do so. So those who are unable to are limited. So on a financial stance, it will implement barriers within the society.
So one of our solutions was to place regulations or restrictions on changing the mental and physical characteristics of a child. The limitation of this is that some countries may not follow these regulations and may continue on with unethical scientific practices. As you can see on this map, most major countries in the world have some sort of ban or guideline that scientists must follow when it comes to editing on human genomes. However, as genetic engineering becomes more prevalent in society, more regulations may need to be put in place.
Another solution for this technology to see if it should really be used on human embryos is research, because we need to make sure that we cover all the basis of whether this technology is ethical or scientifically right to use on humans, because it can call for many risks to our human nature.
That's it.
Okay, a few questions for you. I'm going to start with you, Haley. In the future, what change would you make to your group norms, and how would you expect that to improve the team presentation?
Most similar to like the one we did in the beginning of the year. I think we need to spend more time like together and making sure that we like collide ideas and spend time actually like reading through each other's, not just ours, like stuff that they came up with, so we can better like go off of it and better connect over pieces. So I think overall just spending more time together and practicing.
Okay, and then Jennifer, describe how the content of your team presentation was changed as a result of group discussion.
So as a result of our discussion, we decided to omit stem cell therapy. In Haley's IRR, she brought it up, and we just decided that it wouldn't fit with the flow of our presentation.
Is there a reason why?
We just felt as though we were more talking about like genetic engineering more so than using like stem cells to grow new organs or such.
Perfect. And then Susan, what is a way in which your team's resolution makes you think differently about your own individual research?
So I think we had something about how the restrictions of we should implement restrictions medically and for physical traits like in genetic engineering. And I think in my thing, I think I discussed a lot about plastic surgery, and I think to have regulations like plastic surgery, I think it made me think about how genetic engineering should also have those restrictions.